right. Hey, everybody. We're going to get started in just about a minute. We just want to make sure the feed is all synchronized and ready to go. Chariot Solutions Tech Chat Tuesday for Tuesday, December 22nd. And we'll just start in a minute or two. Okay. As you're waiting, don't forget, you can subscribe to this and be notified, like it and subscribe to it and be notified on YouTube when new episodes show up. So don't forget to click that button. Or if you're a podcast person, you can head over, if you found this through Google search, to chariotsolutions.com/techcast. And that's the page for the podcast. You'll see an RSS and iTunes subscribe link there, or catch it in your favorite iTunes podcast provider. We're on Spotify, we're on Google, we're on Amazon, we're on iTunes, and we may be on other places as well. Okay, well, welcome to Tech Chat Tuesday for December 22nd. I'm Ken Rimple, and joining me today are Keith Gregory. Say hello, Keith.
Helps if I unmute. Hello, everyone.
That's okay. I do this all the time. And Sujan Kapadia. Hi, Sujan.
Hey, everyone.
All right. Welcome to Tuesday. So we've got a couple things going on. Before we start with the actual news, as usual, I would like to talk about some of the things we're writing. So over on our blog at chariotsolutions.com/blog, we have a couple of posts, one of which I wanted to point out. So one of our developers, as he had a little time working on an app, he is an avid golfer, Rod Birish, and he worked with our UX team and then also worked on the app with them, designed a database for a golfing app for the game of Wolf, which I have zero idea what that is, but that's because I don't play golf. But he could tell you all about it. And so he's got this good blog post kind of describing what the requirements are, then going into the database itself, showing the database schema, talking about the different screens that needed to be built from the UX side. So it's kind of marrying the data modeling to the user experience, the user interface, and page layouts. So it's an interesting example of how, as a consulting company, we deal in both the back end of things, writing the application itself, and also dealing with the user experience part of it as well. So we deal with the design, the layout, look and feel. We do this for our clients all the time. So gives you an idea of some of the things we do and how we might approach them. And that's, again, at chariotsolutions.com/blog, and that's called Hunting the Wolf is the title of that. Another cool thing is Tracy Wilson-Rossman has been working with us to put some blog posts together around data, processing, around data engineering. And so if you imagine quotes around the words team data, introducing team data like team whatever, so this is talking about staffing your data team. And so we were discussing the different roles, data architect, a data engineer, data scientist, and data analyst, and so on. So you can look at that and get a feel. As we've been working in a lot of projects now that deal with data, we're constantly running into situations where the team needs a good engineer, a computer science background-based engineer who deals with data in volume and in processing heft. And so, in many cases, you've got people who do a lot of data science but aren't really versed in those skills, and they're busy trying to write the data science stuff and the ML stuff. And then you've got the people on the other side in user interface that also don't have that background. And it's one of those niches that we fill in our consulting services. So get a feel for what some of those.
Ken? Can anyone hear me?
Yeah, I can hear you. It looks like we might have lost Ken.
Yeah, the Dino Nuggets network.
Dino Nuggets back. This is a quick point. I'm in the car because something happened where I couldn't get in the office today. So I'm remote. So if I drop out, if one of you wants to take up the mantle on the post we're talking about and kind of do the jazz hands and spirit fingers, that'd be great. I apologize for any weirdness today. So I don't know how far I got with that, but anyway, so there's a post on data processing. Let's talk about Philly emerging technologies for the enterprise. We are back for 2021. We're still doing one more virtual. We didn't know when all the vaccines would be applied, so we're just playing it safe one more time. And hopefully by 2022, we'll be back together with all of you. But we're doing this online. It's on May 4th to 6th, 2021. And we have some fantastic speakers. Take a look at this first speaker. I never thought in my wildest dreams we would get Alan Kay. Alan Kay is a pioneer of computers. He is one of these people that was at the beginning of the user interface at Xerox PARC. So he created, along with other people, the graphical user interface. He put together the concept of object-oriented programming and turned it into some language constructs. And he's done amazing stuff. He's a 2003 Turing Award winner, and his title is grabbed for pioneering many of the ideas at the root of contemporary object-oriented programming languages and fundamental contribution to personal computing and others. Alan, we reached out to him, and he was absolutely thrilled to do it. He likes different conferences, and he likes a good ask. So I guess we asked the right questions. And he's very engaged. He wants to know all about our audience. He wants to know what we're interested in, what we have as challenges. And so we'll be talking with him over time to come up with a really good keynote that he feels would be perfectly engaging for our group. So thrilled to have Alan Kay. We also have Brian Getz again. He was thrilled to come back. He's the Java language architect at Oracle. I had a good rapport with him over in the last Java at 25 event and other things I've done with him. And he was thrilled to come back and speak at ETE again. We also have ClojureScript big name David Nolan, who has spoken at ETE a couple of times in the past. Great speaker. Whatever he does, it's always an engaging talk. And you can see we also have two more speakers, Matthew Hawthorne from Comcast, who's an engineer there, and I think it's Hawthorne. And we have Lee May Nasri, who also we know, and she is an engineering manager at Spotify, another not small system platform that she's working with. So we'll have a lot more speakers. We're shooting for the same number as last time, around 30. But right now you can register. The early bird is $70. That's it. And that's a very low price to pay for the kinds of people we're bringing in. But we've always viewed this as a community event. We've always had the community involved, and we're glad to have you back. So go ahead and register at phillyemergingtech.com. And you'll notice that we put a little thing up there for every year. So if you want to go back and look at 2020 and see what all the talks were, it's 2020.phillyemergingtech.com. But by the time you watch this, if you hit phillyemergingtech.com, it should go to the 2021 site. Okay, so then let's start off. I brought Keith on this week because I wanted, I'm sorry, one more thing. That's my fault. Also, we are hiring. Wanted to point out that we've got 2 job postings open right now. So we're looking for senior software engineers, cloud facing. If you have AWS experience, it's really helpful. We're certainly getting work in AWS a lot lately. But someone who knows something about programming in Java, Python, Node.js, etc. Some background databases, either SQL or NoSQL. Working with application development frameworks like Spring or Express or Django or something like that. And so you take a look at the posting. We'll put it up in the show notes. We're looking for a few good engineers to join our team. We also are looking for some iOS developers as well. We keep getting a fair amount of iOS work and could always use another developer in iOS. So, if you have Objective-C and especially Swift, that's a good thing. If you're used to connecting up to back-end systems with web services and things like that, and able to kind of work, and independently develop application software, it certainly doesn't hurt if you knew Android, and it certainly doesn't hurt if you know AWS. So we're looking for people, you can see all the different technologies there that they're looking for specifically in iOS, but we're looking for engineers that are cloud-facing, and we're also looking for mobile developers as well.
Maybe feel free to reach out to me, Sujan Kapadia, or Gina Rappaport. If you're interested or have any questions, we'll put contact information at the end.
Yep, good. Okay. And if you hit these posts, that's one place to get to them. We also list them at cherrysolutions.com/careers if you were looking for kind of the current list. But this is as of today, as of December 22nd. So contact us, reach out. Okay. Hey, Keith, so we just finished the first leg of reInvent. So what's happening with reInvent? They're going to have another couple days in January, huh?
Yeah, so it was 3 weeks of sessions, and I guess they had enough material. They're putting in the middle of January another 3 days. They said some 200 additional sessions, and
Wow.
it actually was kind of interesting. One session that I watched on multi-region deployments, they had part one for the initial reInvent, and then the speaker put together a part two, which will be happening in January, so a reason to look forward to it. And it was really interesting. You know, I have a completely different experience than reInvent in person. Number one, you aren't fighting your way through the crowds in the Venetian.
That was insane.
But I think it worked out really well. I liked that they kept their sessions to about a half hour. No questions, unfortunately, when they do that, because I think all of the sessions are pre-recorded. And it was a little bit of a challenge kind of working through the catalog this year, but I keep finding things that I want to go back and watch. And they were really quick. Since everything was pre-recorded, everything was pretty much available online right away. So if you're interested in AWS, you have to sign up for it, but definitely worth going there and seeing what interests you.
They have 3 more days in January. Like it's like AWS reInvent the B side.
Yeah.
Yeah.
Yeah, part two after 3 weeks.
Wow. They have more time to get it together. Yeah, that's great.
I wonder how many things they said in these 3 weeks will either be obsolete or different when they have the second part.
Well, Amazon never deprecates anything.
It's just always more stuff, right? Yeah.
Yeah, it's all new.
Cool. So also the other reason I wanted to bring you on is we've been kicking around the discussions around serverless, and a cloud guru, I think you pointed this one out, had a article called AWS Lambda is winning, but first it had to die, which is a great title. This is from Forrestal Braziel on December 16th, so it's a relatively new article. And his headline here is major feature changes have successfully pushed Lambda workloads into the mainstream, even if function as a service purists feel betrayed. Is serverless winning? Well, that's a debate we'll have probably for the next 6 years.
Yes, at least. Yeah, the interesting thing about this posting is if you scroll down a little bit, there is the Serverless Manifesto, which there it is, and it's worth reading through. But it's the idea of, and of course, everybody says serverless has a server, but it's the idea that you don't see the server, that you don't have to manage it, that you don't have to patch it, that you just focus on your application code and deploy it. And I like the idea. In practice, there are definitely some challenges, which I think we could spend an entire dev news talking about, especially you've been running into a lot of them recently. But the point of this article was that this is the Serverless Manifesto. This is what the team at Amazon this is what we want to do, and how in 2020, 4 years after Lambda was introduced, all of these things have changed. So, for example, just some of the things I remember, the permanent storage lies elsewhere. And, back when you first wrote Lambda, you'd get a thing like, okay, you want to store data, you have 512 megabytes in your Lambda container for temporary stuff that's going to disappear 15 minutes from now. Better store it in Dynamo, S3, database, whatever. Now they're looking at, okay, Elastic File System, which is basically NFS for the cloud. You can mount it into your Lambda containers. And that's sort of the idea, is that the idea of the post is that Lambda came out with this manifesto of kind of revolutionary ideas, but to become usable and really adopted, it's softened that manifesto a little bit.
Yeah, there's one above that, just above that. If you scroll up about there, right there. Thanks, Becca. No machines, VMs, or containers visible in the programming model. I mentioned this in the last TechChat Tuesday. We were talking about the announcements recently of them shipping an actual Docker container, official one for Lambdas that you can now deploy So they're letting you deploy your Lambdas instead of these zip files uploaded to S3, and then you have to tell, through CloudFormation I've uploaded my latest one, deploy a new revision. I'm assuming this is just more developer helpfulness, because it's always felt really clunky to deal with Lambdas as these separate uploaded zip functions, hasn't it?
Yeah, I have a half-written blog post about what I call the chicken and the egg, which kind of contrasts Lambda deployments, especially the serverless application model, with more of a traditional software deployment where you build out your infrastructure and then you deploy onto the infrastructure, versus with Lambda, you really kind of have to have your deployment. You start with your deployment and then you build the infrastructure around it.
Yeah, right.
Keith, I had a question around this one with the containerization, which I find attractive as a developer, that I can think in the context of a container and kind of have some standard packaging around it. But my question is, one, are Lambdas already containers? And two, are they already containers that get pulled from a registry and then get installed and executed or run as a Docker process, essentially? I shouldn't say Docker, but you know what I mean. And then
Fargate something.
And then with this, does this incur any performance penalty by now packaging it as a container?
So I haven't worked with deploying Docker to Lambda yet. Last few weeks have been a little bit crazy for me, but I'm assuming that it's the sort of thing where you configure your Lambda to go out to ECR to pull the container. Fairly early on, after Lambda was released, they offered the ability to create your own Lambda runtimes. And there's a whole section buried in the Lambda documentation that tells you how you basically create an executable that will run inside a Lambda. And I can't remember the name of the software package, but really early on after Lambda came out, that was leveraged by some software package. So I know the Golang meetup that I was part of, they were really excited that now they could write Lambdas in Go. And I think Go is now a supported language or a supported runtime for Lambda. So I'm guessing it's fairly similar, that you write your container and you can, as long as you follow the programming practices that Lambda requires, you can just deploy your container instead of, as you had mentioned, Sujan, Lambda runs in a container. They have pre-baked images that they pull down, deploy your zip file onto, and run.
Okay.
Now, where this gets really neat is that if you're using like native libraries that aren't available on the Lambda container, you have to kind of jump through a few hoops to make those work. Now you can build up your own container with native libraries with whatever you want, and it just works. So that's kind of a really neat thing.
That can be really liberating. And the interesting thing is, like, the container model just makes local development of them so much better too. So I was working with this LambCI Lambda container earlier, and I wrote a whole blog post around like doing everything this way. And it was a week before reInvent, and reInvent came out. I'm like, well, I guess I have to redo all this. But it's a more official way of doing what I was trying to accomplish, which was develop locally in containers that have your AWS credentials in them through environment variables, and then go ahead and deploy, the tested Lambda the normal way. But now you could deploy that same container and be ready to go.
Right.
So it makes it simple.
Not to belabor this, but Keith, you bring up a really great point about being able to use other libraries and utilities and things inside your container that weren't available with the original runtime. Because another point here mentions how now Lambdas can run for 15 minutes with 10 gigs of RAM and 6 vCPUs. So combine that with the ability to use whatever library you want, you can write some pretty powerful code. Now, whether that's a good thing or not is another story.
We'll have to figure out the use patterns.
To give you an example of this, a few years ago, I was working with a team that wanted to do video processing. FFmpeg, not available on your default Lambda build. So even though they could use a library that was a wrapper around it, and we figured out a few ways to make it work. But we ended up just saying, the way to do this is we build up a container, install FFmpeg, install our software, run it on AWS batch. Plus, there was the issue that 512 megabytes of storage wasn't enough for what we were doing, and you couldn't mount EFS at that point.
Okay, let me move us on because I know we have other topics to get to. I got an operational notification this week about Lambdas. Speaking of Lambdas, and them changing on the Sandbox's personal health dashboard. What they were doing was they had an interesting named policy. It was like the AWS Lambda, like full access or full control or whatever it is, and then one for read-only access. And then they've deprecated the existing managed policies, which are basically like cooked up policies they deploy for you that you can attach through IAM, I guess, of course. And then they've deprecated the existing ones, and they've created new managed policies, which are slightly more restrictive with an underscore in the name. So if you're using those managed policies, the baked-in managed policies for, executing Lambdas with full access and or read-only, as of I think it's January 15th or 20th or something like that, you will not be able to do that anymore. They will fail that a policy. They won't let it attach to any new roles, users, or groups. And then you'll have to change your CloudFormation or Terraform or whatever template you're using to use the new ones. But Keith, you were talking to me about this yesterday, and you said it's also a bad idea even to do these managed policies generally. So talk to me about what your approach might be.
Yeah, so on the one hand, I like the idea that Amazon has come up with these managed policies, not these managed policies that incorporate some of the standard operations that you might do. For example, they have a base policy for Lambdas that would be the Lambda execution role that has the ability to either run it inside or outside of a VPC, create its CloudWatch log group if it's running inside a VP, allocate an elastic network interface. Those sorts of things are useful. Unfortunately, I have to switch windows for just a second. I didn't have it up. There are some 400 or 600 managed policies covering every single service that essentially give you full rights on all of those services. Please don't do this. Really, please, 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 please. If you're writing software and deploying in the cloud, take the time to define a policy that is specific to the permissions that you need for your software. So I can certainly see the thing that I do have up on my screen is I compared these two policies. So for example, the old policy would give you the ability to do anything on DynamoDB. Drop a table, create a table, insert rows, whatever. Same thing with CloudWatch events, also known as Event Bridge. It would let you do a very large number of roles on IAM that really give you the power to do anything. If you have a vulnerability in your code, you could find that your system was compromised. So yeah, my very strong recommendation is if you're developing an application, use Terraform, use CloudFormation, custom tailor the permissions that you need for your application so that it can't accidentally gain access outside.
Yeah,
that's a super important point, principle of least privilege.
Right.
Yeah.
And I want to bring up something, Ken, you remembered I really pounded on you to do this for a project a while back, is the idea that you have these policies that define what the application needs for permissions.
Yeah.
And you set up developer roles so that, most of us as developers, we're sitting doing our work. We don't want to be slowed down, so we have admin rights.
All about us.
And that's kind of a bad idea, right? You need admin rights as a developer sometimes in a sandbox, not in production. But you certainly don't want to be doing your work with admin rights and then come back after the fact when you're about to deploy into production and say, oh, what permissions do I really need?
Totally agree.
So a development practice that I'm very strongly believe in is that when you're doing development, when you're testing locally, assume a role that has exactly the same permissions as your deployed application will have. And Amazon makes this very easy by separating out permissions and roles. So with Amazon, you tie a role to a principal, either a service like Lambda or EC2 or a user. with a trust policy, and then you have the actual permissions the roles grant. So it's really easy to set up a role, 2 roles, I prefer, a little bit of duplication, that both refer to the same IAM policies. One lets your Lambda run with that policy, one lets your developers run with that policy. And yeah, it will give your developers a little bit of friction as they're programming and say, oh, I guess we need the ability to do a scan on DynamoDB as well as a query. That pushes them to go back, update the Terraform, to give that permission, and now it's just done.
So you're saying instead of one role that attaches to multiple types of principals, have a role per principal type?
I like that, yeah.
Yeah.
It again, it's every time you try and do 2 things with one object, you're kind of getting yourself into a danger zone.
Okay.
Yeah, you might widen it out a little bit too much in the Venn diagram of things, right? That connect together.
Right. Let's look at a fairly well-known breach of a few years ago where people were able to get access to buckets, to the contents of private buckets. And if you could tie that down to just like a Lambda, even getting access to the access credentials should not give you the ability to fully access the buckets.
Mm-hmm, mm-hmm. Okay, good tips. I'm going to jump to the next one, which is Dan Boykus had brought up, one of our consultants. He's been on this show a couple times. Found a great article on why the M1 Apple chips are so darn fast. And
a fantastic article.
Say again?
This is a fantastic article.
Yeah. I mean, I was talking about some of these things just because I was listening to some podcast about it, but it boils it all down. So basically, the system on a chip is smoking even up to almost Xeon processors in terms of processing power for things it's doing. Now, it can't run 128 cores, but it can if you're doing Photoshop, if you're doing anything where you're compiling something and processing and you're forking off threads, it's a monster. It's almost always faster than regular Intel. So this goes into all these things. I don't know if did you read through this, Sujan? Did you want to?
So yes, the discussion about the unified memory architecture between the GPU and the CPU, and RISC architectures and how it approaches out of order execution to be able to run multiple instructions in parallel is extremely interesting. So if you're interested in computer architecture,
that's great.
It's an awesome read. And it gives a lot of credence to RISC-based architectures these days versus CISC-based. And I mean, Intel really should be worried. So the thing with RISC is all your instructions in this case are 4 bytes. Instruction sizes do not vary, So it's able to do the out of order execution much more efficiently. It essentially fills up a buffer of instructions that it can run in parallel. And it'll take a chunk of instructions and say, okay, what are the dependencies between these instructions, essentially a graph, and say, what can I run in parallel? And the piece of, I guess, the piece of architecture, whatever, that runs that determines that it's called a decoder. Mm-hmm. Intel has decoders, AMD has decoders, and they usually have 4 decoders per processor. In this case, the M1 has 8 decoders. It's able to fit more because of its transistor die process, and so it's able to do a lot more of that and fill up a much larger buffer. So the speed of any single core, I guess they call them Firestorm cores, at the clock rate that they have is actually super blazing fast compared to Intel and AMD. And the fact is, like, they could actually increase the clock rate at the risk of producing more heat, and they could add fans and do that. I mean, this doesn't have fans. This doesn't produce anywhere near as much heat or draw as much power. So there are faster processors out there, but they're not actually faster. They're only faster because they're clocked at a higher rate. So Apple has room here to even improve more, which is, I can't imagine what's going to happen in the next few years for Apple if they continue with this, and how the other competitors are going to respond.
The Mac Pro that will come out from this is going to be insane. It'll be a supercomputer. So what we're seeing here is, as Becca's scrolling, thank you, Becca, for this. If you're scrolling down, like typical processors are boarded onto a motherboard with all the other chips and buses that connect them together. But if you scroll down a little further, there's a section where it talks about like CPUs like to get small chunks of information and process them very quickly. So you want to have a lot of tiny things going through, but GPUs want to eat a ton of memory and pull it in from main memory and process it and do whatever kind of calculations it does on it. And with unified memory, thank you, Becca, with unified memory, they all just directly draw from the memory, which is on the system on a chip, as opposed to having to fetch things in through caches to their buffers to get things done. So, and I'm not sure I'm describing that right, but the bottom line is that it's all directly available, and it's not something where they have to compete for it. They all have access to
it's
it.
high bandwidth, low latency memory. Now, the trade-off, which they meant, this article really does a good, I think, a balanced job of describing it. The trade-off is you can't upgrade your memory. The memory is really baked into the system on a chip. But Apple is basically like, well, SSDs are so fast now, you can essentially use the SSD as old-fashioned memory.
That's insane, by the way. That's just a great concept. They've really been working on this.
I wonder if that's actually, well, I wonder if that bears out in practice, though.
Well, at least it's to some level closer to it, right? So like we've always thought of it as offloading things to disk, so to speak, and so it's been this slower thing. But these really fast eMMC or whatever the bus is, they're much faster, and so they can really serve closer to what a almost like main memory would be. But wow, just a really good article, I think.
Well, one thing, it's 16 gigabytes of memory on the chip, if I recall.
Yes.
Which is just a couple of years ago, all but unimaginable. And taking just the physical distance now, instead of looking at, is that a nanosecond? I think 6 inches is a nanosecond. It's now all memory accesses go in just a tiny fraction of a nanosecond. It's kind of the idea of the whole reason for going with large-scale integration or very large-scale integration in the first place is it's all there. It's all right there. There's no path for your signals to travel.
And it's, cooler. I mean, you mentioned like the no fan thing. The only one that has a fan, well, the only one that doesn't have a fan is the MacBook Air. And it will throttle at some point. I've been hearing tests like after about 9 minutes of total usage, they start throttling back the cores. So if you were like looking at doing video editing or something, you might want to think about the Pro or the Mini, just because they have a fan. But beyond that, I mean, just for general purpose workloads, my God, it's so cool when Apple does something like this or any other company does something like this where they have to they kick everyone else on their butts and say this is a different way of doing it. And they own everything about it. So they own the hardware, the operating system, the chipset. So they can make these changes and they can make changes to their APIs to support it. So they've got a good running start. It'll be interesting to see what companies like HP or, IBM or anybody else could do to do something close to this. I think they're a couple of years ahead of everybody.
Well, I'm going to throw in the obligatory Amazon reference, and Amazon has basically gone down the same path with their Graviton processors.
Right. Very cool. All right, so that's that. So check that article out. It's by Eric Engheim. He's a guy out in Norway. I love his writing style, and he's a good read. It's on Medium. If you're not on Medium, I apologize in advance. A couple other articles this week are on that. Another one coming up. Don't panic for Kubernetes and Docker, or Kubernetes, or whatever you want to call it, KS. So Kubernetes recently said that they are no longer using Docker as their runtime after v1.20. And it turns out that that's not that big of a deal because both Docker and Kubernetes are based on the container runtime interface, which Docker implements. Meaning that when you build a Docker container, you're building a container runtime interface compliant container. So Docker was just the first runtime to use it. Your processes will still function the same way because they all are based on the same way that containers are laid out, that the file systems are layered on each other, the entry points and everything else. That's all part of the container runtime interface standard. So if you're curious, if people are saying, what are we doing now? We're using Docker for everything, but Kubernetes is dropping it. Don't panic. It's just simply that they're changing to have a different runtime where they have more control over it. So that's the main thing here. All right. So that is that article. To that aim, we also had another interesting one. Now, I was listening to my podcast one morning and I saw, I think it was late last week, is ECS deprecated? So now, Corey Quinn, Keith and I know about, and probably Sujan, you probably know him too, but Corey Quinn is what's that?
I do because of Keith.
A cloud economist. I love that title. He is a snarky, silly man. I love his podcast from that perspective, but sometimes he goes a little far. But this is an interesting one. So what I like about this one is he's looking at people complaining and saying that they've been investing time in ECS, but they're worried about EKS winning the argument. EKS is the Elastic Kubernetes service that Amazon has. I know Keith wants to talk about this too. What he did was he reached out to some of the people he knows at Amazon and asked the person who leads the ECS and EKS teams, hey, is ECS done? Are we deprecating it? Are we getting rid of it and moving to EKS? And he said, no, I think it was like 46. There's some number of percentage that's very significant of workloads that are going on in containers are still ECS. That there are some major internal services that I now forget about on the top of my head that Amazon uses that directly use ECS and Fargate for their launching. So no, it's not lost. It's just that there's such a demand out there for Kubernetes, and Amazon is responding to that demand and providing that, but they're also providing ECS. And Keith, if I had to ask you to explain, I'm going to put you on the spot a little here. Why one or the other? What would lead you down the road of ECS?
I knew this was going to happen.
What's that?
I knew this was coming.
I know. I have to do this to him.
So
ECS or EKS? What would go in a different direction?
What Ken knows and Sujan doesn't is I've just put the final draft of a blog post of why I don't like Kubernetes.
I knew the opinion. I didn't know there was a blog post coming, so that's cool.
So, they very much serve different really use cases. And while the title of the blog post is I don't like Kubernetes, it has its place and it certainly provides a very valuable service. So Kubernetes gives you basically an entire deployment environment. It handles your networking for you. It handles your scaling for you. It handles scheduled jobs for you. And those are just the things that I used in a recent project. So the difference is ECS is one component that fits into the Amazon ecosystem. ECS is simply a way to run containers. And for networking, it ties into Amazon networking. You can bypass that a little bit, but it ties into Amazon networking. For scaling, you use an Amazon scaling group. I think that's baked into the ECS service. These systems are complex enough, I can't keep track of them. Load balancing, you use an elastic load balancer. So the targets are really different. EKS gives you a complete deployment environment where you basically manage everything you deploy on it. ECS gives you a deployment environment for containers to simplify deployment of just a tiny part of your application. It fits into the entire AWS ecosystem. Where EKS and Kubernetes in general, I think, are very valuable is the idea of a cross-cloud or cross-environment deployment. One project we worked on with Kubernetes on Azure, one of the concerns was the client did not know if they wanted to stay on Azure. And so Kubernetes was one way that, okay, Azure doesn't work out for you, we can go to GCP, we can go to AWS. So that's kind of my take on the difference.
Okay, that's great.
I hope you saved some nuggets for the blog post.
A few.
All right. So yeah, that's my Snark Patrol quote there. And here's another one. We've been kicking around TypeScript for a while, and a lot of people love it. But if you work with it a lot, sometimes you'll pull your hair out for basic things, because it's a typing system, and I'll just use the word Scala. Excuse me, sorry. And so some languages make typing systems really, I don't want to say overly complex because it's skewered for that, but they can be complex to work with. So this person, I love always getting like the alternative view of things, but this is another Medium article. The person who wrote this one, and could you scroll to the top? Sorry, it's Ilya. Thank you, Ilya Sudanlitsky. I said that wrong. I apologize, Ilya. But anyway, so it talks about some of the challenges you have in type systems with, the type inference and the layouts and the way you put things together and some of the syntax that you're working with. Type inference is one of those things that can be kind of difficult to work with if the implementation is rudimentary. So the one thing that he talks about here is nulls, getting started. And so the person, Tony Hoare of null references, created null references, said, I call it my $1 billion mistake. It was the invention of the null reference in 1965. At that time, I was designing the first comprehensive type system for references in an object-oriented language. So bottom line, he says that he created something that just makes all sorts of problems like null pointer exceptions and vulnerabilities and system crashes when you don't set things up right. And he's like, what have I done? And the point here is that null references break type systems, and the type systems have a hard time with them. So you have all sorts of things like, optionality of checking to see whether the thing is there, ? Do something, all sorts of goofy checks you'll have to do, or guards in your code. So if you can make the code a little bit larger, Becca, and that function capitalized there, right? So you have to do goofy things like this. If the string is nullable, right, you'll get into situations where, if you do that, then you can write code that directly accesses the string, and otherwise it won't compile and move forward. That's good type checking, right? But I think if we scroll down a little bit, keep going. No, up a little. Never mind, I won't find it. Oh, that's probably it right there. So, for example, in other languages, there's like actual compile time checks for things like that. In TypeScript 2 has added support for non-nullable types. You can turn on a feature to enable it called strict null checks. But if it's not the default, you have all the goofy problems with it. And then they go on to other things as well. I didn't have enough time to really prep for this, as I always say every week. But if you scroll down a little bit, we have things like immutability. I don't think immutability is part of TypeScript itself. You have to kind of go out of your way to make it work. Like, for example, spread operators don't do a deep copy by default. So JavaScript's actually a little bit easier because you can use like immutable JS and JavaScript and have immutability if you really want to, or other things like that. Anyway, take a look at that article, see if you feel anything about it, or if you feel the pain, therapy, whatever that might do for you. And then I thought, why not just be obnoxious and find something in TypeScript to annoy people? If you look at the next thing and I'm just looking at serverless and really digging into it, there's a bunch of libraries apparently out there for serverless TypeScript developers. And I wasn't aware of these as I was starting to get working with it. But so, for example, some of them are things like MIDI.js, which is like a middleware stack. So, for example, you could standardize operations you execute before, after, and around Lambda. It feels like advice in Spring code. And it can handle things like parsing HTTP content from the gateway, dealing with event validation, formatting and handling responses and errors. So this is an interesting one I'm going to take a look at and see what's what. Then there's a Dynamodb Toolbox. Again, these are TypeScript libraries to help you when you're building serverless Lambda functions. So you can define TypeScript classes to represent the different entities in DynamoDB, which is kind of interesting to see. And, if you don't use that, you use low-level API, you have all sorts of goofy monikers around your types. So this makes that easier to work with. Here's one we always deal with, JSON schema to TypeScript. If I see one more library for this, I think I'm going to lose my mind. JSON schema to TS is a package developed by, and I'm quoting the article, Thomas Arabart. statically generates TypeScript types from JSON schema definitions. So if you're using JSON schema, then you can generate types from it. And so that you might be able to use that for some of your infrastructure as well. And then serverless framework TypeScript, if you're using the serverless framework from serverless.io, I believe it is. There's TypeScript service file definitions that make your life easier to work with when you're dealing with serverless definition files. So serverless is, we talk about different serverless frameworks. There's the SAM serverless application model framework for Amazon, and serverless is another one that's been around actually longer than SAM, and it's kind of multi-platform. But you have to set up all of your Lambda functions in a YAML file, and that gets pretty annoying to work with. This gives you TypeScript definitions for creating those, so you get all the IDE help. Kind of like if you build with the CDK in Amazon to build your platform with typed programs to build what would normally be CloudFormation, this is a similar concept. Okay, so that's another one, serverless TypeScript service definitions. And then I believe there's one more in here, TypeBridge, a small library. Okay, this is his library. I don't want to say his, the writer's library, scoped around event bridge, events, and buses. And then they mentioned a few others. So, something to think about. I'd like to hear what you're using. If you're doing Lambdas and you happen to use libraries for them, tweet us at TechCast and let us know whether you're doing that or if you're really following the Lambda should be as tiny as possible, minimum number of libraries, keep it small kind of philosophy that a lot of people focus on. The other option is to use Lambda layers and embed the library in the layer. I suspect that's what a lot of people are doing here. But, making a bloated giant Lambda could be an issue. A, because it might take longer to load it up and start it, but B, also it counts as part of the deployment size. Just curious what you might be using out there. Frederick Bartholet is the writer of that. All right. Hey, guess what? Ruby 3 is released. Does anyone remember Ruby? I'm teasing. But Ruby was on 2.x for as long as I've used it. So 1.8 was, I think, the last, or 1.9 was the last 1.x version. But for probably 10 years almost, it's been on 2 point something. And now there's a Ruby 3. I just thought that was interesting. It's in release candidate 1. So it looks like they're rounding out to get that up and running. So let me just pop up my copy of the page here. So it has a couple of features. One of the things is it has static code analysis, which could be interesting if you're a Ruby developer. It'll do like a read through your program and try to find problems. There's an RBS, a language described types in Ruby programs. There's a type checker basically going through it. So it's kind of modernizing the language a bit to find problems with types and things like that. There's also a type prof, which is a type analysis tool that comes with it. There's an actor model, Ractor, Ruby actor. So I guess they're catching up with Scala and actor type specifications there. So those are the major features. There's a whole bunch of little things as well for those of you who are using Ruby. I just thought it was interesting. I know for a while at Chariot, we were doing Ruby on Rails projects when other people were as well, because it was what customers were asking for. And some of us really liked working with it, but just curious that it got to Ruby 3 at this point. And then 2 more articles here that I have. Sujan, did you have one?
I did. I can go at the end, though.
Okay.
Continue on with the dynamic languages train.
Yeah, I might as well. So, hey, Lisp. Lisp is back. Well, Lisp never went away. It's been 1950, whatever. But, I know Clojure developers are kind of like Lisp and Java, and certainly it is a Lispy programming language, and that would not be understated. But it looks like Hacker News has a whole bunch of articles around Lisp these days. So this is just a quick note. This writer here, Victor Parmar, a couple months ago had pointed out, 2019. Well, this is old. Well, see, this is the kind of stuff that happens with Dev News. I throw an article in, it shows up on Hacker News, and it's an old article. But let's just go down the road. Do you know anyone who is still using Common Lisp? Because that's what a lot of this is. I don't know. Any comments from either of you?
No, I've just worked with Clojure and people who
Clojure.
have worked with Clojure.
I know we had one person at Cherry who had used Common Lisp in the past, but just curious here. Never mind. We'll move on off of this one. This is a little bit of a bust. Let's talk a bit about
Slashdot still exists.
What's that?
Slashdot still exists.
Doesn't it?
Wow.
But here, not great news here. So due to COVID-19, Apple is closing nearly a fifth of its retail stores. So that's another big, hit on the COVID-19 pandemic. Is every California store? Wow. Let's see. Every California store, all 4 in Tennessee, all 3 in Utah, all 4 in Minnesota, 2 in Oklahoma, stores in Portland, Oregon, Anchorage, Alaska, Omaha, Nebraska, Albuquerque, New Mexico are all closed this upcoming week. 16 additional stores in the UK, Mexico, and Brazil. Now, are these closing down permanently? I'm hoping these are just temporarily shut down. Yeah, I think these are just closing down temporarily. Thank God, right? Good. That's good news that it's not permanent. So I think they can weather the storm, certainly. But, another big hit, unfortunately. Sujan, you had one content piece here.
Yeah. So I know we don't have much time left, so I'll try to be fast about this. If folks don't know, or I think many folks may not think about it every time they open their browser, they're really, it's a VM, right? And it runs remote code, so it's a remote code execution vector. But anyway, that's just all joking aside. It is essentially a virtual machine that's running code on there, and for most part, it's been running JavaScript code for the last several years as the WebAssembly spec has matured and more browsers are supporting it to varying degrees. Not all of them yet. WASM, WebAssembly Module, is essentially a way to run native code via the browser. One of the popular languages out there that's used for that is Rust. So Rust can work with WASM, and you can create, essentially the tool chain allows you to generate JavaScript bindings. So your code gets downloaded to the browser. It gets compiled on that machine on the browser, in this case Rust, and then will run in the browser, and it can talk to JavaScript, and JavaScript can talk back to it. The idea being that you can get a much better performance because you're hitting the metal and it's compiled for that architecture. The size of the code that's being shipped over the internet to your browser is smaller because JavaScript is a lot larger, the way it's transported over. So in this case, they're using WASM and Rust and the Web Audio API to do pitch detection.
Oh, cool.
So it basically gathers a number of audio samples and then runs a well-known algorithm out there to do pitch detection. But what I thought was really cool is just, hey, you can do this. And by using things like Rust and WASM, you can get much faster performance, so you can hit that 60 frames per second because you only have a little bit of time on the UI thread to get some stuff done to not be laggy. So while some of this stuff can run off the side, anything you do on the main thread, if you're going to do things that are UI intensive, they need to run, in this case, like you're saying, 16.7 milliseconds.
Wow.
1,000 milliseconds divided by 60.
Yeah,
to,
right.
Be able to keep a smooth UI going. So the ability to have multiple threads, the ability to do Rust on the browser allows you to be able to gain those speeds. So the reason that I found this interesting is we're doing some audio stuff right now for a client, and it's in mobile apps. And initially we were kind of prototyping it in Chrome Web, and with a Node server, and then moved it over to mobile native as WAV file processing. But with things like this, I'm not saying this is the right way to do it. It feels very hodgepodge, and it's not supported by a bunch of browsers, so your mileage may vary. But the more and more powerful these things get, the browser keeps eating into other forms of app distribution and execution, and I think that trend is going to continue, for better or worse.
So I don't want to assume that you're building this and looking at this yet, but so my understanding of WebAssembly was that it would be the way it delivered the JavaScript code was it compacted it to the very smallest amount possible, so it ran really fast. Is there a binary interface to WebAssembly now for some of these browsers? Is that what that is, or a bytecode interface? Is that what it is?
I haven't done WebAssembly myself, so I can only talk about what I've read. So from what I've read, it essentially sounds like, okay, let's say I'm writing something in Rust. I'm using the WASM toolchain to compile and generate bindings that can then be called from JavaScript and vice versa. And then you package that as a WebAssembly module. That module is what is shipped down to the browser. It needs to be compiled, right, locally. Right. You can't compile on some other architecture and get the same native performance. So it does just-in-time compilation in a VM on the browser locally, and then runs.
Gotcha. Okay, very cool. Yeah, I've really not paid much attention to WebAssembly, but
I haven't either. The audio thing caught me because we were looking at some audio related stuff for a project.
Yeah, I know, and it's one of those things where I've seen people do Doom or Unreal Tournament kind of stuff in WASM. They translate stuff, and it's amazing.
It definitely feels like one of those let's do this because we can.
Yeah,
sort of things. But when you look at things like Google Chromebook and stuff that are not really full-fledged OSs, and what you can install or not install is limited. I mean, you have the Android App Store, but not everything runs well on Chromebook.
Right.
Something like this, the more mature it becomes, is going to allow platforms like that to do more and more.
Yeah, definitely. Be good to try to get an interview with somebody on WebAssembly for the show. I'll have to take a look at that. All right, cool. Thank you, Sujan. Okay, so that is the Tech Chat Tuesday for December 22nd. Again, remember, Philly Emerging Technologies, the enterprise is open at phillyemergingtech.com. You can sign up for the $70 early bird now. I would sign up soon. Get your ticket, get it ready. And that's 2021 at phillyemergingtech.com. Thank you very much, Becca, for that. And if you have any comments, please tweet us at TechCast or email techcastfeedback@chariotSolutions.com.
I like your t-shirt, man.
I wonder where it came from.
Yeah,
I got this at reInvent. When we went through the Venetian 150 times.
Actually, a nice looking shirt.
Very comfortable. I like it. All right, yeah. So, hey, listen, Keith and Sujan, thank you so much for being with me this week. Really appreciate it.
Thank you.
Thank you.
All right. See you. Oh, and we're gonna be off for a week. We're gonna take next week off. Holiday vacation, but we'll be back first week of January. So see you then.
Happy Festivus. Bye, guys.
All right. Bye, everybody.